now that we already derived the equations for constructive interference and destructive interference, let's do a little bit of summary to try to see everything in a single picture. Okay, so just now we already talked about the path difference over here. This column here represents the path difference. So if you're at the central bright fringe, you know that the distance from S1 to the central bright, the distance from S2 to central bright is the same. So there's no path difference. But the more you go upwards and downwards, you see that the path difference will increase to 0.5 lambda, 1 lambda, 1.5 lambda, 2 lambda, so on and so on. Okay, so knowing this thing, we have already spent the previous video to derive an equation for both the constructive interference situation and the destructive interference equation. Then we get the equation for y, where for constructive interference is y is equal to m lambda d over d. So the m here will be 0. Okay, so it's m lambda d over d with m substituted with 0, just as what you see in the path difference. For the first bright fringe is m lambda d over d, but this m here is substituted with 1, just as shown in the path difference over here. Followed by the second bright fringe, which is m lambda d over d, but m substituted with 2, based on your path difference over here. It's still quite clear cut. For the dark fringe, for the first dark fringe that you notice, okay, going from the central, the first dark fringe that you notice over here, the y will be m plus half lambda d over d, but m you are going to substitute 0, so that after you add a half you get 0.5, so this is 0.5 lambda d over d. The next dark fringe that you see is the second dark fringe. So for this second dark fringe, it's also m plus half lambda d over d, but the m is going to be substituted with 1, so that 1 plus half will become 1.5 lambda d over d. Okay, so the general idea is here. Let me expand the discussion to include a full table showing everything. Now I'm going to focus on talking about the idea of how do you count a bright fringe. Okay, there's two ways to name a fringe. Okay, one way for sure is that the center fringe, the central bright, is always called a central bright fringe, but occasionally you can call it as a 0th order bright fringe. Okay, so there are two ways to name a fringe. One is by adding the word order, one is without the word order. If you are talking about the word order, if you include the word order inside, basically the idea is the value that you put in front of the order will be the exact value of the m that you will be substituting into the equation for y. Okay, if you know that here you need to substitute 1, then this is called the first order fringe. Okay, if it's dark, then it's first order dark fringe. Let's say look over here, you want to know which order is it. You know that for equation you want to substitute 2, then definitely this is the second order bright fringe. Okay, if you have order inside the name, the word order here just means that the value, the number before the word order will be the value of m. It's just very clear cut. The number before the word order, all these values here will be the value of m that you will substitute in the equation for y. Okay, that is for the word order. But if your questions involve naming a fringe as second bright fringe or third dark fringe, the word order doesn't exist in the sentence. There's no word order here. Then the way you think about the number in front of it has to be a little bit more careful. Okay, if there's no word order in front, what you need to do is you need to do a bit of counting. Okay, so the central bright is always called a central bright, but going out from the central bright, this is the first time you see a dark fringe, right? Going out from the central bright, this is the first time you see a dark fringe, so this is called the first dark fringe. Okay, then the next thing you see is a bright fringe. This is the first time you see a bright fringe outside of the central bright. Beyond the central bright, outside the central bright, this is the first time you see a bright fringe. So this is called a first bright fringe. So basically you're counting how many fringe have I observed starting from the central bright, but not including the central bright in the count. Okay, so not including this is the first bright fringe that I noticed, so this is first bright fringe. This is the second bright fringe that I noticed, so this is second bright fringe. Okay, counting downwards also the same thing. If you go downwards, this is the first time that you see a bright fringe after the central bright, so this is the first bright fringe. This is the second time you see a bright fringe, so this is called second bright fringe. Okay, so if you don't have the word order, what you need to do is you need to count from the central bright, but not including the central bright. Okay, let's talk about the dark fringe. This is the first time you see a dark fringe, so this is first dark fringe. This is the second time you see a dark fringe, so this is second dark fringe. Okay, going downwards is also the same idea. This is the first time you see a dark fringe, this is first dark fringe. This is the second time you see a dark fringe, this is second dark fringe. Okay, there's no 0th time of seeing a dark fringe. There's no 0th time of seeing a dark fringe, there's no 0th time of seeing a bright fringe. Okay, you are excluding the central bright, so you are not taking it into account. And outside of central bright, the first thing that you see is called the first bright. The first dark that you see is called the first dark. It's just very clear-cut counting. Okay, that is if we don't have the word order. Then you need to think of the word counting. But if you have the word order, then basically what this order will try to say is the value before the order will be the value of m that you're going to substitute in the equation. Okay, so these two, as you can see, they have different numbers in front of them sometimes. Especially if you look at the dark, first dark fringe is not the first order dark fringe. First dark fringe is the 0th order dark fringe. Second dark fringe is a first order dark fringe. So you can see there's a bit of difference between having the word order and not having the word order. If you are not having the word order, remember to count. If you are having the word order, remember the value in front is the value of m. Okay, and they are not exactly the same. And this is the case for dark fringe. Dark fringe, they are not the same. So if I say this is second dark fringe, don't immediately say m is equal to 2 because there's no word order in front. If there's no word order in front, what you need to do? You need to count slowly, find the second dark fringe. Oh, this is the second dark fringe. What should I substitute here? Oh, the first dark fringe I substitute 0. So the second dark fringe I should substitute 1. And from there only you know m is equals to 1. You are substituting 1 plus half lambda DOD. Okay, so without the word order, you have to be a bit more careful. If you see the word order, it's quite straightforward. The value in front of it will be the value of m. Okay, so this is what many students might make mistakes of, whether they notice the word order or not, or the order, whether the word order exists or not. Okay, so this is the first thing you need to take precaution. Okay, the m is still the same m that we discussed. The delta L is still the same delta L that we have discussed. Y is still the same, but there's something new that we introduced here. This is called the phase difference. So phase difference means by if you differ, if the path length it's longer by one single lambda, you know that one lambda is one cycle, right? So one cycle is 2 pi radian. So you just change the lambda to become 2 pi lah. Okay, so if it differs by one lambda, one wavelength, you know one wavelength is 1 times of 2 pi radian. So 1 times 2 pi. Okay, if it differs by half a lambda, so it's half of 2 pi radian, so it's just pi radian. Okay, so basically just if you want to find phase difference, what you need to phase difference, right? Yeah, if you want to find phase difference, just take the path difference, but you change the lambda. You know that one lambda is equal to 1 cycle, so you change the lambda to become 1 cycle, which is 2 pi radian. That allows you to find the phase difference. Okay, so there are a few important things here in this video. One is you have to differentiate whether there's a word order or there's no order in front of your bright fringe numbering. If there's a word order, use the value in front as m. If there's no word order, you have to count carefully in order to know where is the fringe and to know what m to use. Okay, this is especially true. You need to be extra careful when we involve dark fringe. For bright fringe, they are the same as you can see here. Bright fringe, they are the same, but for dark fringe is where you might notice that there's difference. Okay, so to get m, technically you need -1 now. Okay, if you want to take shortcut, you just take the value for dark, second -1, that's your m. Okay, so that's the first thing to take into account. Second thing is you have to be very clear when to use this equation. If it's constructive, you use m lambda d over d. If it's destructive, you use m plus half lambda d over d. Where the m, you have to be very careful what kind of m substitute based on what kind of information is given to you. Then the third thing to take into account is your phase difference. You can just change the lambda for the path difference. One lambda is equivalent to 2 pi radian, so just substitute lambda with 2 pi, then you're able to get the phase difference. So this is a complete description of what you can observe for a double slit experiment. This is the pattern, and this is the path difference, the phase difference, the distance from the central bright, and how do you name all of these fringes. So that's it for double slits explanation. Thank you very much.